Okay, so hello. So this is my submission for Dojo Game Jam 7. So I present to you Chance Master. So we are all familiar with chess. What chess is, but how do we bring it on chain? So why do we need to bring it on chain? So first of all, it's a game and it's pretty fun. I got into chess around a year ago, and yeah, I've been loving chess. I'm not too good at it, but yeah, I like chess. So, why do we need to bring it on chain? So it's fun, yes, but don't you think that if we just bring chess into on chain, the newbies would never think of it as, it gives it. They would never believe themselves that they could, beat the best people, or even I don't know, like maybe climb the leaderboards, earn some money or any incentives or something like that. So that's where we bring in a chance element to chess. So here, as the logo represents, dice knocking out two chess kings. So that's what Chance Master is to me. So yeah, so let's first talk about what Chance Master is, how it works internally, and then we'll get on to the demo. So Chance Master, we use uh, zero knowledge proofs to validate and tell the legality of the move. So I remember I had this idea back in Dojo Game Jam 6 as well, but I couldn't find the time to build it. And I did get on to building lightly, but I realized that it was not feasible for me at the time, since I had no knowledge about zero knowledge proofs, and I was doing everything on chain. And would you guess it? Chess is a very computational heavy game. So doing everything on chain cost me, I'm not talking figuratively, I'm talking literally. It costed me more than a billion gas tokens. More than a billion gas not tokens. Yeah, more than a billion gas. So during the building phase itself, I stopped the plan immediately, and yeah, I was moving to Tokyo as well, I think. Yeah, so that's why we need zero knowledge proofs in this. And these zero knowledge proofs are then verified on chain. So it makes for a very nice anti-cheat mechanism. So what I also used to struggle when I was building games with Dojo is that not just games in Dojo, any on-chain games, I would always think about how can I prevent cheating, because in a lot of games, money is involved, uh, especially on chain. So how do I remove any element of cheating? So that's where I thought about zero knowledge proofs, because I've heard of the concept, but yeah, uh, got to implementing it this time around. Next up, we have real-time multiplayer applications. So we actually utilize the Torii indexer from Dojo's SDK, and we subscribe to a lot of events and models and entities, and we show a completely uh, what do you say, a live multiplayer mechanism in this game. So that's something I found very cool. I didn't know about indexing prior to learning Dojo. Yeah, so let's just go through the landing page real quick, and then we'll get on to the demo. So yeah, let's talk about what is dice chess. Basically, what is Chance Master? It is a dice chess game. So what do we do here? So we roll three dice. Now each dice will show. Each dice is obviously having six faces, and each of the face can be either a pawn, a knight, a bishop, rook, king, or queen. So, whatever options you get from your dice, uh, the three dice, you can only choose one of those pieces and move them. So this gives a chance to newbies to compete against the grandmasters even. Uh, Luck can shine on any day, and they might be able to win. So yeah, these are just some general things about it. So yeah, let's talk about the zero knowledge setup. So I have used Circom circuits. in this project, and I have used Garaga to generate a Starknet contract for my circuits. And then I am using Garaga again to generate the call data uh, for my on-chain proof. Yes. So I'll get back to the Garaga in a second because I ran into a problem with the cartridge SDK. And yes, I did mention it to the organizers, and yeah, so they added it as a bug to the cartridge SDK, I think. Yeah, so yeah, we'll get back to it. So yeah, that's about the project. Now let's take a look at a live demo. So as I click on to play now, I go, okay, sorry, I can't play it right now. I need to log in with cartridge first. So let's start at 50. 50 is a good number. Yeah, uh, please don't judge me on how many accounts I've created these past 3 days. Yeah, so let's create a fresh account and we approve the contract with some functions. Yeah, so I have my account ready over here, and this is a Brave browser, so this is a different client than this is the Firefox browser. So yeah, let's connect a different client. Let's say 51 and sign up real quick. Real quick. Yes, verification. Okay. Yeah. So now we have our accounts ready. Now let's enter the matchmaking queue. So a new account. Okay, it's asking me to update the session once again. Okay. Yeah. Now it should run smoothly. So right now in the queue there are 0 players. As soon as my transaction is submitted, I get that there is 1 player in the queue. And now let's enter the queue for this guy as well and update. And submit. So these are popping up the first time I connect a new wallet. I have to sign a transaction manually. So yeah, as you can see, those 2 players got matched, and now we will be redirected to the game page. Yeah. So yes, as we have an active game, we are redirected to the chess game page. Okay, not quite yet. Okay, what's the issue? Let's refresh. Okay, usually it's um, subscription based, so you don't have to refresh. That was a bit weird. Anyways, yeah. So as you can see, this client, this is me on this client, and it is White's turn, and we have 60 minutes each to play the game. And yeah, this is Black, and those are my moves and whatever. Okay, so let me show you the first feature. So let's roll a die. So yes, let's just roll a die. So, uh, and a transaction was sent for this dice, and it was picked up by my Torii indexer over here. So dice rolled, yes. And if you see, and this is where I roll the dice, and here on the other client as well, the results are reflected. So it is a complete WebSocket live interaction between the clients. So here is where I am going to talk about Garaga once more. Reason being, Garaga proof is quite a long string, a long array of string, a long span of files, sorry, and they are not able, I am not able to send this transaction using cartridge SDK. So let me just show you. Yeah, so as soon as okay, sorry. Oh, okay, would you see it? I got shafted by the first rule itself. I can't move any of these players, so I'm just going to resign. So yeah, so I sent a resignation, and the game is over here, and on the other as well, the game is over. So I can now play again and enter the queue once again. Which should be, yeah, I enter the queue again. Um, Yeah, yeah. So now we are in a new game, and yeah. So this is all luck based. Even I cannot control what I roll. Okay, so this is like a jackpot. So uh, I can play anyone. So yeah. So here's what I want to show you. So as soon as I drop this piece, uh, an API call will be made to my prover, which will generate a Garaga proof for this whole game and the move, and it takes around 40 inputs, and it generates a proof for me. So the proof generation is successful, but the problem comes in this part. So as you can see, there was no error that was shown to me over here. But as I click on the submit button, there is an unexpected error about this thing. Yeah. So I have informed this to the cartridge team and they are looking into it. Yeah. So I just want to show you that sending a transaction is actually possible um, using a ready account. So I'm just going to resign here and yeah. I'm Yeah, so let me just connect to ready client real quick. And yes, it should be done, I think. Yes. Okay. Yeah. So I'm gonna take this chance to show the WebSockets in a better way. So let me close this client real quick. Okay. So yeah, this guy is in a queue, and let me just make a transaction of NQ over here, and we should be redirected. Yeah. So as soon as the game started, we got redirected to this page. So it is my turn on the board over here. So, oh my God. Okay, okay, yeah. Yeah, one thing I forgot to mention about this game is, okay, so the way everything works in this game is you roll the three dice. If you can't make any move, so yeah, so the my opponent he rolled these three on the dice. So I can make a stalemate claim, right? So yeah, I made a stalemate claim that my opponent is stalemated. Now the only way that the opponent can the only way the opponent can refute the claim is by making a valid move, something, whatever is the move that he might make. So that's the way I handle checkmates and stalemates, and for that reason as well, I have added an hour timer here. Yeah. So the reason for that is again computation. As you can see, my Garaga process takes about 2 to 3 seconds to generate a valid proof. If I included the checkmate checks as well, it was taking much longer than that. So I had to get rid of the checkmate checks. Yeah. So these are all other different functions that you can call. So if your opponent times out, you can call this function, and the win will be transferred over to you, and you can adjudicate the claims. So yeah, and accept the opponent's claims that yeah, you're saying right. Offer draw, accept draw. Yeah, so just standard chess stuff. So I'm gonna resign again and hope for the best. Yeah, I resigned. I think it acted in the same block, so that was I got that error. So I'm running the queue. Uh, Okay, so I'm in a live game right now. Yeah, so my opponent, the ready client, has the white pieces. That's perfect. Now let's roll the dice real quick. Confirm, and let's see what he gets. So he got pawn. Okay, perfect. So now I can demonstrate what I've been trying to demonstrate for a long while now. So yeah, uh, I am able to send this transaction using a script that I wrote. Just feed in the game IDs and the dice. So these are inputs that my so these three inputs are what four inputs are what my backend takes and generates a Garaga proof. Yeah. Um, okay. So there's a rook and king pawn. So rook is four, I think. Yeah, rook is four, king is six, and pawn is one. And so obviously you don't have to do all of this. This is all done programmatically uh, by the uh, by the client. But since the cartridge SDK is bugging out a bit on me today, so I'm just showing you that these things are possible. Obviously, you're free to skip over this part if you are satisfied. So 23 would be 32, 35, I think, right? Yeah, so it should be game number 35. And yeah, let's just make this move, right? Yes. So let's just make this move. So yeah. Yeah, let's just hold on. Yeah, so the move has been made, and as you can see, the WebSocket line pushed the move on itself. So yeah, that's what I wanted to just show that if cartridge kind of works with me here, then yeah, this is definitely possible, and we will have a brilliant dice chess game on chain, fully on chain on Starknet. Yeah, so that has been my submission. And yeah, I am very happy with my submission, and I learned a lot. Learned a lot about cartridge. Learned a lot about indexing. I learned a lot about zero knowledge. Yeah, it was pretty amazing. Yeah, so let's just roll the dice. Yeah, I got a pawn as well. Yeah, so proof is generating nicely. It's just cartridge cannot call this one. Yeah, so this is my uh, Garaga proof. Approximately 2,500 files in this. Yeah, whatever. When I submitted, yeah, unexpected error on this one. Yep, so that has been my submission. Thank you very much for giving me this chance to participate in and yeah, learn a lot. Thank you very much.